in Vidyavardhaka College of Engineering. He is an expert in the field of earth science and resource management, and he's an expert in geomatics engineering. Today, he's with us to share his knowledge on geomatics engineering. He will help you to crack GATE 2021. I request Professor Girish sir to take over the session.
Thank you, Kanmani Madam, for a nice introduction. Firstly, I would like to welcome you all the participants for 12th day session 2. Wait for a moment, I am going to be presenting the slides. So today, I'm going to be brief onto the advanced mitigation tool, that is a remote sensing and GIS. So coming to that, the geomatics engineering. So in the 5th day, second session, my friend Professor Ranjan will focus on principles of surveying and also the various factors considering in the survey. So today, I am more focuses on the photogrammetry and remote sensing, focusing mainly on the scale and the flying height of the aerial photographs, and also the basics of remote sensing, GIS, and a part of GPS. Coming to that, remote sensing. Remote sensing, it is not a new subject. It is a oldest subject. So oldest subject in the sense in the 60s itself, the innovation of telescope. So slowly every decade by decade, adding a new technology and improve the olden techniques. So that's why earlier we called it as a photogrammetry. And then from photogrammetry to the aerial photographs, then adding a technology, then remote sensing. To that remote sensing, we have adding a software called GIS. Now combined together, we have various applications of GIS, that is a Geo-informatics. So coming to that history and development of remote sensing. So initially, the invention of telescope. So whatever that the various purposes, initially the people use telescope, and then slowly adding a technology to apply that various factors in the field. So in that concept, initially like balloon photography in the year 1858, and then first aerial photos in the year 1859, and pigeon cameras, using pigeon cameras, the taking of photographs in the year 1903, and then the advanced way, the collection of data by aircraft and spacecraft from 1947 onwards. So coming to that, the definition part of aerial photographs or whatever that photogrammetry or remote sensing. So if you see the image, you have a very clear indication. So there will be one the sensor, a device that will capture the object. So with this, the image, if we define that definition, so photogrammetry in general, a graphical representation by means of light without any physical contact with the object. So if you see that a camera device, it will capture the object, so without any physical contact. So behind that, there are a lot of geometrical various the aspect involved, but whatever the various the geometrical classification involved in that, but graphical representation by means of light without any physical contact, that we called it as a photogrammetry. Coming to that, the basics of photogrammetry and aerial photographs. So present day, we have a satellite imageries, but earlier, because of lack of technology, because lack of innovation, So people will try to prepare aerial photographs. So for preparing that aerial photograph, they have adopted numerous technology. So and then finally they have come out with a superimposed one aerial photographs. But present day the condition will be different, the satellite sensor system. So depending on that our requirements, it will going to be captured that data, and that captured superimposed data that we are going to be easily downloaded or received in the receiving station. So already I tell you the definition of photogrammetry, the graphical representation by means of light without any physical contact with the object. And similarly, the definition, the aerial photographs. The aerial photographs, these are the photographs from an aircraft or any flying object. The photographs are taken from a fixed position on or near the ground surface, and then the interpretation and then the overlapping for getting a superimposed aerial photograph. When we speak of aerial photographs, so initially in the year 1859, Grasper first aerial photograph was taken from an captive balloon. So the aerial photograph, whatever that the area covered, at an altitude of 1,200 feet. So of course, the whatever that aerial photograph, that first aerial photograph in the year 1859 by use of captive balloon, the name of that balloon was called a Queen of Air. So the first aerial photograph was taken with the captive balloon called Queen of Air. Coming to that, more about the photographs. We have a terrestrial photograph. So day by day, there will be innovation in the technology, adding a new techniques that the photographs will going to be taken. So whatever that photographs which are taken, then for the first time, the people will adopt that photographs for the survey purpose, for documentation purpose. So that's why when it comes to that survey purpose, then slowly the technology will be enhancing and adding a new technology, and the more and more usage of these aerial photographs. So coming to that, the photographs, the terrestrial photographs and the bird's eye view photograph. So when we say the terrestrial photograph, generally, whenever we go there to the hill station, we are capturing an area by camera. We call that photo will be collectively called a terrestrial photograph. But other hand, the bird's eye view photographs. So the photographs taken from the aircraft or maybe from the helicopter using a friction camera are termed as aerial photographs. So when you use the word friction camera, it is nothing but it is not an ordinary camera, an advanced sensors camera. By that advanced tool cameras, the whatever that the capturing of area, that we called it as bird's eye view photographs. So coming to that, some important the remembering terminologies in the aerial photographs, aerial cameras. When we say the aerial camera, a friction camera specifically designed for use in the aircraft for capturing the data or collecting the data with aerial cameras. And coming to that, some other terminologies, the aerial film. When I use the word aerial film, a roll film with a high sensitivity, high intrinsic resolution power, and dimensionally stable emulsion support. So depending on the aerial film only, that we are collecting the capturing the data, and then the interpretation has been carried out. So coming to that, some other the important terminologies to be remembering in the aerial photograph, aerial photography and aerial photograph. So the words look similar to the same, but the meaning will be wide differences. So when we say aerial photography, it is an art, science, and technology of taking aerial photographs from an airborne platform. And then coming to the aerial photographs, the photographs taken from the airborne platform using a friction cameras. Friction cameras in the sense advanced sensor cameras. So if you see that another end, the images of camera. So we have well aware of this, the various the the varieties of precision cameras. So most of the time, advanced camera, the photographers, they have well frequently used to collect the data or capturing the images. And then some more important terminologies that always remembering in the study of aerial photograph, image interpretation. So whatever that various factors that we are going to be collect the data by various precision cameras. So the image interpretation is of more important. So in that image interpretation techniques, identifying the images of the objects and judging their relative significance. Most of the time, the image interpretation, that judging significance, that all depends upon the pattern of color. So the pattern of color that mainly depends upon the electromagnetic spectrum or electromagnetic waves. So later on, we come to that part of interpretation techniques. And coming to that aerial survey, we are simply saying that aerial survey are the photographs which are taken from the aircraft by fitting a cameras, but that needs to be a proper planning. So without planning, we cannot conduct a aerial survey. We cannot carry out aerial photographs. So some of the important set of parameters to be considered for aerial surveying, either helicopter or a flight. So in a specific planning way that we are going to be do the aerial survey of an area. The parameters considered like altitude of flight, that will be considered as a H, then focal length of camera, that will be defined by F, and then size of photographs, how much the size, the whatever that area that we are going to be covered, the size, and then alignment of land to be photographed, then lateral overlap, that depends upon the deviation angle, the lateral overlap, then number of photos in each flight and parallel flight line. So in this particular aerial survey, that all depends upon the number of photos. So in a specific manner, we are going to be planned to collect the number of photos, and then the whatever that collected photos from the aerial survey, that will going to be superimposed. Finally, we have called it as aerial photographs. Then the scale of flight map will be considered. Then speed of aeroplane. So that will also be one major parameters, the speed of aeroplane. And then time interval of successive photographs. So when that the speed of aeroplane, one moves in particular direction. So that will be like matches with that the successive photographs at a regular interval time. So if not, so definitely we won't get a proper the aerial photographs through aerial survey. So these are the important set of parameters that we are going to be considered, particularly in the planning of aerial survey. So coming to that, furthermore about the types of aerial photographs. So that parameters, there are several ways that aerial photographs are going to be taken. But always, whatever that various method that we are going to be followed, but always the photographs are based on the position of the camera axis. So whatever that like types of aerial photograph, may be a vertical photographs, or it may be a low oblique photographs, or high oblique photographs, or any means of oblique photographs. Always all the photographs are mainly based on the camera axis. Coming to that, the type of photographs, vertical photographs. When I say vertical photographs, while taking the aerial photographs of two distinct axes, so once I fix the photograph for a particular area in a vertical axis, like two distinct axes are formed from camera lens center, one towards the ground plane and other towards the photo plane. So by this the action that we are going to be capturing the photo, we called the vertical photographs. So vertically, that particular area will going to be covered such the vertical axis, a camera axis of a photograph will be called vertical photographs. Coming to that, some other types of photographs, low oblique photographs. So these are the aerial photographs with an intentional deviation. The photographs are taken with an intentional deviation in order of ranges between 15 to the 30-degree deviation. So if you see the figure, like always we have a vertical axis camera. With respect to that vertical axis camera, like intentional deviation of 50 to 30 degree, under that condition, whatever that photos are with respect to that camera axis, the photographs are taken for a particular area that will shows the images of that area, and such photographs are very much the importance, particularly in the recognizing surveys. And when we say that different types of photographs, if you see the vertical and oblique photographs, oblique, that includes either it may be a low oblique or high oblique. So low oblique and high oblique, that always different, like differences depending on the intentional deviation. So if you see the vertical photograph image for the same area, if we take a low oblique with an intentional deviation, with a deviation of 15 to 30 degree, the camera axis will be a deviation of 15 to 30 degree. The image will be looks like this. That very much clearly seen in the oblique photograph. So apart from that, the most of the time we have covered the photograph with high oblique photograph. So in this particular photograph, like photographs are obtained when the camera axis is intentionally inclined about 60 degree. So the range of intentionally inclination varies from 40 to 60 degree. Whereas in the case of low oblique photographs, the intentional deviation will be varies from 15 degree to 30 degree. Here 40 degree to 60 degree from the vertical axis. Such photographs is useful in the most of the recognizing surveys. So apart from this, coming to that, furthermore about the types of aerial photographs. The types of aerial photographs are varieties of aerial photographs that are always based on the scale. So depending on the scale, the like whatever that the like responses are a imagery resolution that we are going to be easily identify, and objects are like whatever that entities in that photographs. So in the images that it clearly shows the various patterns of scale, like scale of the photograph scale, the first one in order of 1 is to 15,000. The second one, 1 is to 20,000. Then we see the 1 is to 40,000 photograph. In all these, there will be a slight variations in the resolution of images. That all depends upon the scale. So when we come to that scale, particularly when map creation, either it will be in the aerial map or whatever the general, the various types of a map, we always fix the scale. So depending on the scale only, the various attributes or entities in that map. So similarly in the aerial photograph, the most of the time that we have like a type of a photographs, before we considering that type of a photographs, we have fixed the scale. So with respect to this, most of the time, like expected question in the gate, like focusing on the scale of a map and also overlapping of photos. When I say the overlap, once that a number of aerial photographs are taken for a particular area or any specific area with a specific planning, whatever that recognizing or whatever that various parameters to be considered, in that factor, once we are going to be collect a number of photographs, and then all the photographs are combined together or overlapping together, and then finally we have prepared a aerial photograph. The reasons for overlapping, like the present day, the sensor cameras in the satellite like devices, so that will automatically collect a particular area, a particular path of deviation of the area, and superimposed imageries are directly downloaded. But earlier, when prepared the aerial map, a lot of behind that, a lot of techniques, a lot of various preparation and planning will be required. Similarly, this one of the techniques they have adopted for getting a superimposed aerial photograph, like overlapping technique. The reasons for overlapping, like arrangements of mosaic. So whatever the number of collection of photographs that are systematically arranged, and then once they are arranged, all the photographs, the collected photographs through the aerial survey, and then remove the errors due to the displacement. And then after removal of errors, and then they will try to get use that photographs either like the way they required, either in a 3D view, and then avoid the repetition of aerial survey. For these four important reasons, overlapping of aerial photographs, and then after superimposed, we get real aerial photographs. Coming to that, the overlap, there are two types of overlap. One will be a longitudinal overlap, another one like lateral overlap. When I say the longitudinal and the lateral overlap, always like the way that portion of photographs, when we collect a aerial photographs or taken in a aerial photograph through the aerial survey, how much area will going to be overlapped before taking the one photo to the another. So based on that condition, we have a longitudinal overlap and a lateral overlap. The overlap between the two photos in order of 50 to 70%, we call longitudinal overlap. Whereas in the lateral overlap, the overlap between the adjacent flight lines with side overlap should be 20 to 30%. So within that restricted condition, the before like in the initially the collection of photograph itself overlapping, and then further all the collected photo will be superimposed through the alignment of overlapping techniques. Then finally we get aerial photos. But generally there are two important overlapping like longitudinal overlap and lateral overlap. Coming to that more importance that we are focuses the scale of aerial photograph. Already I will say most of the time, like most of the map in any map, either in the survey map or boundary map, road map, country map, or any varieties of map, we have seen the scale. So that will be the one, the most important considering the aspect, particularly in the aerial photograph. There are three methods to compute the scale of an aerial photograph. So when you come to that method of the aerial photographs, like the first method, it includes by establishing a relationship between photo distance and a ground distance. Relationship between photo distance and a ground distance. In that particular establishment relationship, provide the corresponding ground distance, that is DG, are known for which the distance of an aerial photograph, that is DP, are measured. In such cases, the scale of aerial photograph will be measured as a ratio of the two, that is DP versus DG. Then the establishment relationship between the photo distance and ground distance, that is a scale of photograph, will be measured in terms of DP is to DG, that is a ground distance, that is DG, is to the like distance of aerial photograph. Coming to that, the method one, I just show the problem how we are going to be fix the scale corresponding to this particular method. The first problem, like the distance between the 2 points of an aerial photograph is measured as a 2 centimeter. The known distance between the same 2 points on the ground is 1 kilometer. Compute the scale of aerial photograph. Then, as usual, that already I will like mention the equation. Scale of photograph will be equal to dp is to dg. So dp is the distance of photograph measured, that is 2 centimeter, and dg is the like distance between the 2 points of the ground, that is dg, that is 1 kilometer. So then scale of photograph equals 2 centimeter into that kilometer that we are converted to centimeter, 2 centimeter into 1 lakh centimeters. Then 1 is to 1,00,000 divided by 2, then scale of photograph will be equivalent to 50,000 centimeter. Then we represent that one unit represent a 50,000 units. So finally, the scale of photograph, that is SP, will be equal to 1:50,000. So this is the way that the scale ratio will be fixed in the method 1. Coming to that, some other method like establishing the relationship between photo distance and a map distance. So there the ground distance, here the map distance. So in this case, the distance between 2 points, both on the map and the aerial photographs, enable us to compute the scale of the aerial photograph, that is SP. The relationship between the two distance may be expressed as the photo scale is to map scale is equal to photo distance is to map distance. Then we can derive that establishment relationship by equation. The scale of photograph is equal to dp is to dm into MSF. So SP is the photo scale, then dp is the distance of photo or photo distance, and dm is the map distance. MSF is the map scale factor. With this, the equation that we are going to be concluded that establishment in the method 2. For this case, a problem like the distance measured between 2 points of a map is 2 centimeter. The corresponding distance of an aerial photograph is 10 centimeter. Calculate the scale of photograph when the scale of map is 1:50,000. So scale of photograph is equal to dp is to dm into MSF. So that is 10 centimeter. That is the distance of an aerial photograph. Then 2 centimeters. 2 points of a map is 2 centimeter. Scale is 1:50,000 into 50,000. Then 10 centimeter into 1 lakh centimeter. So 1:1 lakh centimeter by 10, that is 10,000 centimeter. The 1 unit represent the 10,000 units. Therefore, the scale of photograph is 1:10,000. So this is another set of condition, the fixation of scale. So another one, the last, the method of establishing the scale in the aerial photograph, that is relationship between the focal length and the flying height. The focal length F, flying height H of an aircraft. So to derive the photo scale by using the formula like scale of photograph is equal to focal length is to flying height. That is SP is equal to F is to H. For this condition, a problem, compute the scale of an aerial photograph when the flying height of aircraft is 7,500 meter and the focal length of camera is 15 centimeter. By using the formula, that is a photo scale formula, F is to H, 15 centimeter is to 7,500, that is a flying height of aircraft, 7,500 into 100. So 1:7,50,000 by 15. So scale of photograph in this relationship, establishing relationship is 1:15,000. So this is the way, like the 3 important methods, the establishment of the scale of aerial photograph. So with this, the scale of photograph. Now we move on to that, the remote sensing. So when I speak of remote sensing, like the similar definition, that is whatever that we derive with respect to that photogrammetry or aerial photograph. So if you see the figure, remote sensing, an eye in the sky. So when I generally define the definition, remote sensing is nothing but looking a large area from the sky, which can be done by aerial survey or through satellites, which revolve around our Earth at a height of 700 to 900 kilometer or more than that. We called remote sensing. And some more definition for defining it is the measurement or information about an object without being in physical contact with the object under the study. So most of the time, the definitions are varies from the various the study factors, but always we define it is the measurement of object without being in physical contact. We call the remote sensing. So coming to that, more about the remote sensing. There are important stages in the remote sensing process. So earlier, the aerial photographs, they have some parameter to be considered to collect the aerial photograph. When I come to the remote sensing, through this important set of stages, the process of remote sensing, there are 7 important stages in the remote sensing. The first one, origin of electromagnetic radiation. Second one, transmission of electromagnetic radiation from source to the Earth's surface and its interaction with the atmosphere. Interaction of electromagnetic radiation with the Earth's surface feature such as forest, water body, soil or snow, etc. Then transmission of reflected or emitted electromagnetic radiation to the remotely placed sensor. Then sensor data output, data processing and analysis, and generation of output. So these are the 7 important stages involved in the process of remote sensing. So the process when I see like the naturally how it will be involved from one part to the another. So whatever that the process we are saying like origin of electromagnetic radiation, importantly the origin from the main sources, that is radiation energy from the sun. Once that radiation energy from the sun that illuminating the earth's surface, automatically like interacting with the every object and also interacting with the various layers of the environment, and then once again it return back. So when it return back, like there are several the radiation energy, the reflected or re-emitted radiation return back by illuminating the object. When it return back, so there are sensor systems at certain altitude with a various platforms. Either it may be a sensor platform like space-borne platform, air-borne platform, or balloon-based platform, or maybe a ground-based platform. So any the sensor system that devices that will capture that the reflected energy radiation, that captured energy will be like pass on through the antennas, and that will going to be downloaded and processing in the ground station. Once that the data processing through the system, so once again through that processing preparing a soft copy as well as the data product, and then that will be transferred to that the interpretation, the visual interpretation techniques, and then after that visual interpretation, like digital preparation of that the product. Finally, after the digital the preparation of that product, finally through the systems outputted hard copy we have through this whatever that hard copy that we have obtained, then only finally we are going to be a decision making on that particular concept. So totally all these processes include the whatever that we have say the 7 important stages of remote sensing, from origin of electromagnetic radiation to the generation of the like in the end that is the output. So coming to that further more about electromagnetic various concept of remote sensing, that is electromagnetic spectrum. So when I say the electromagnetic spectrum, like the behind this we have a electromagnetic radiation waves. When I speak of electromagnetic radiation, wavelength and frequency are of most important. When I say the wavelength, it is the one wave cycle measured as a distance between the successive crest, and always that wavelength will be measured in terms of a micrometer. When I speak the electromagnetic radiation, the frequency, it is the number of a cycle of a waves passing from a fixed point to a another like end point, and it will be measured in terms of a hertz. So totally like EMR will be always considered as a transverse wave with electric and as well as magnetic field at right angles to each other. And finally, through the equation that is V is equal to C by lambda, that is the frequency velocity is equal to the velocity of light divided by wavelength, that will going to be determine the radiation waves. Coming to that electromagnetic spectrum, when I say the electromagnetic spectrum, so like most of the time, the matter with a body always a temperature greater than 0 degrees Celsius. And furthermore about this electromagnetic spectrum, so the spectrum ranges always varies with the like one wave pattern to the another. So when I say the electromagnetic spectrum, it is always based on the device which can be used to observe the particular type of energy. So this is the base of a remote sensing in discriminating one matter from the another. So most of the time, the different elements are combined to form the compound. Each compound has a unique spectrum due to its unique molecular structure. With this base, we have a electromagnetic spectrum. There are various the portions of spectrum. The spectrum may be gamma rays, X-rays, ultraviolet rays, infrared rays, microwave, radio waves, longer waves. So these are the various the spectrum, the portions starting from a shortest wavelength to the ended with a longer wavelength. So the shortest wavelength will be the gamma rays. Gamma rays will having a wavelength frequency in order of less than 0.01 nanometer, ended with the longer wavelength portion, that is a radio waves more than 1 kilometer, maybe 100 kilometer, 150 kilometer. It goes on a longer wavelength. But in between that, we have a numerous the electromagnetic spectrum, X-rays, ultraviolet, infrared, microwave. All are varies with the frequency. Among all the various spectrum, in particularly in the remote sensing part, we have very much importance given to that a small portion, a visible portion. So the visible portion, it is located in between the middle of ultraviolet and infrared the spectrum. That small portion will be very much valued, particularly in the remote sensing techniques, because the visible portion, even it is a smallest portion, so it is the only the one portion, it is greatly characterized with a set of colors. No other spectrum we never read in terms of a color. That's why apart from the gamma rays, X-rays, ultraviolet, or any other waves, we give more importance to the visible spectrum because it is only the one portion characterized with a set of color. In this, the spectrum, once again, the wavelength frequency varies with the color, that is a VIBGYOR, violet to red. So once again, the frequency of the electromagnetic spectrum visible portion, wavelength will be varies with 0.4 micrometer to a 0.7 micrometer. 0.4 will be the shortest wavelength portion in electromagnetic spectrum visible portion. 0.7 is the longest wavelength portion. It is characterized with a red color. So furthermore, coming to this, the electromagnetic spectrum. So most of the time we have always expected question focusing on the wavelength frequency of visible range. The visible portion, particularly the blue, green, red color. In between that, the various shades of color, but we always focuses the important set of color like blue, green, red. The wavelength frequency of blue is 0.4 to 0.5 micrometer, green is 0.5 to 0.6 micrometer, red is 0.6 to 0.7 micrometer. So always keep it in the mind. In the visible portion, shortest wavelength will be the violet and longest wavelength will be the red. And coming to that, further more about infrared, the radiation. To 1.3 micrometer. Middle infrared, the frequency of wavelength will be 1.3 to 3 micrometer. Thermal infrared, the frequency will be beyond 3 micrometer. Coming to that, another important the electromagnetic spectrum, microwaves. So active form of microwave, that is the radar. Microwaves, the frequency will be ranges between 1 mm to 1 meter. So you will be very much careful, particularly the wavelength frequency of the visible portion. Coming to that, the interaction of electromagnetic radiation. Always in the interaction of electromagnetic radiation, absorption and scattering process are important. When I speak the absorption process, that always depending upon the three important constituents like water vapor, carbon dioxide and ozone. So three constituents absorb radiation. Either it may includes including that constituents like ozone, carbon dioxide and water vapors. There are so many times the process of absorption is very stronger in certain wavelength band, not in all the band. In a specific wavelength band, the absorption process is very much effective. And the spectral bands in the atmosphere always continuously transmits you the energy, a portion of energy. Such a continuous transmission of energy will be called atmospheric window. Or in other words, atmospheric window, that is the electromagnetic radiation that passes from the atmosphere, known as the atmospheric wind. So if I see that figure, it shows how that the various radiation, whatever that, either it may be a shorter wavelength or longer wavelength or intermediate wavelength portion, all are continuously transmit from one layer to the another. Such process will be called a atmospheric window. And second, another one, the important the interaction of electromagnetic radiation with the atmosphere, scattering. So scattering always it will play a most important the role, particularly the radiation spectrum study. In that scattering, there are different types of scattering. Based on that processes, we have a selective scattering, non-selective scattering, Rayleigh scattering, and Mie scattering, or MIE scattering. So scattering, it is nothing but like unpredictable diffusion of radiation by particles in the atmosphere. Always the process of scattering depends upon the relative size of particles and the radiation wavelength. The distance of radiation traveled through the atmosphere. So the scattering process that always depends upon the how that radiation will travel through the atmosphere. So the process of scattering always the adverse effect on remote sensing, because it always reduces the image contrast and also changes the spectral signature of ground object as seen by the sensor. So most of the time, the process of scattering always adverse effect on processing of images. And coming to that, another type of scattering, Rayleigh scattering. So particularly like atmosphere molecules and particles, the different size of radiation wavelengths inversely proportional to the fourth power of wavelength. So such the waves, interacting waves will be called the Rayleigh scattering. The shorter wavelength electromagnetic radiation is scattered more by this mechanism. So particularly, anyway, if you find like the short wavelength radiations are scattered because of the process Rayleigh scattering. So most of the time, whatever that the interpretation of sky, color of sky, so the color of sky like looks blue, it is because of due to the various short wavelength electromagnetic radiation scattered that looks a blue color because of the Rayleigh scattering. So the Rayleigh scattering effects on photography and can be minimized by use of the filter. So by adopting the various techniques, we can minimize the effect and proper way like the transmission of the wavelength is going to be protected. Coming to that MIS scattering. So particularly the MIS scattering or MIS scattering, the atmospheric particles diameter equals the energy wavelength being sensed. So that all the MIS scattering that depends upon how that atmospheric particles, the various diameter of wavelength being sensed. Either it may be a wavelength varies between 0.4 micrometer to the 0.7 micrometer. So most of the time, the MI is scattering caused by the water vapor and dust. So always it influences the longer wavelengths, whereas the scattering influences the shorter wavelengths. So coming to that, another one, the scattering, non-selective scattering. It occurs when the particle size is much larger than the energy wavelength. The non-selective scattering, water droplet, causes the scatter, that is a splitting nature. And it always like not depends upon the wavelength with respect to the like the repetitive, the pattern of the radiation energy. So non-selective scattering makes a fog and cloud appears white or whitish appearance of sky. The blue color of sky is mainly because of due to the Rayleigh scattering. If the cloud looks the white, that mainly because of due to the interaction of non-selective scattering. With this, when we look the ideal remote sensing processes, it includes a uniform source of energy, a non-interfering atmosphere, energy matter interaction at the Earth surface, super sensors, real-time data processing, and supply system. These are the like 5 important ideal remote sensing system. So with this ideal remote sensing system, we have the remote sensing process or the collection of data. So coming to that, some other important factors to be considered in the remote sensing with respect to that electromagnetic spectrum, spectral reflectance curve. Spectral reflectance curve. When I speak a spectral reflectance curve, the characteristics of Earth's surface features may be quantified by measuring a portion of incident energy. These are the whatever that the image represent the various curves like green curve, red curve, black curve, blue curve. So these are all the standard, a generalized reflectance curve with respect to the materials. So with that base, the characteristics of a Earth's surface features may be quantified by measuring a portion of incident radiation. So always like that wavelength will be, the reflectance wavelength will be measured in terms of like reflectance versus incident. With that the various pattern of reflectance versus incident, we have measured the reflectance characteristics property through the spectrometer. Coming to that, the image, we have seen the various reflectance curve. So one curve I am going to be interpreting like a green curve. So that is the one curve that clearly shows the vegetation pattern. When I say that the curve that depends upon the reflectance, the varies with the various bands of curve. In some of the portion, reflectance is very high. Some of the portion, the reflectance is very less. That depends upon the scattering effect and also as well as the reflectance characteristics property of that particular vegetation. Particularly, most of the time in the part of vegetation, like compound leaves called chlorophyll, the chlorophyll they have always strongly absorbed the radiation, particularly in the red and blue color or red and blue wavelength pattern, and always reflect green wavelength. So particularly in that particular portion of wavelength, the green portion, always it will reflect the radiation energy. So that's why most of the time the reflectance curve, the curve pattern will be always varies with the healthy condition of a type of vegetation. So depending on the condition of a vegetation, the curve varies. But in general, the like most of the time, the part of vegetation, the chlorophyll strongly absorb the radiation in the red and blue color. And that's why in the near infrared, the curve will be reflectance characteristics up to a 45%. So once again, it comes downward. Starting with 10%, it goes up to reflectance will be up to 45%. Once again, depending on the chlorophyll component properties, it will be comes downward and form a curves called the reflectance curve. Coming to that, another curve, a soil. So if you see that red line, the soil curve. So most of the time, the reflectance of soil that depends upon the many factor, like a type of a soil, a type of vegetation, a type of a weathering surface, a type of what about the moisture content of that soil, and then among all other various the considerations, the more important consideration, composition of soil. So depending on the percentage of iron content or like magnesium content or nickel content, depending on that factor, the reflectance varies. But most of the time, the reflectance of soil will be varies with 30 to 40%. Whereas the reflectance of vegetation always reflect 50%, but soil reflectance always varies with 30 to 40%. Coming to that, another one, the water. So the clear water and whatever that various curves that we have seen in this picture. So always when we speak of clear water, the water will have a reflect in a, like most of the time, it has a reflectance 10%. So particularly, like water always looks a blue or green in color because water like has relatively very low reflectance, particularly in the blue portion, and high absorption reflectance near the infrared wavelength. So that's why, because of low reflection, particularly in the blue portion of a electromagnetic spectrum, it always looks a color blue and shades of green. So, but in general, these are the important set of the reflectance curves. They are very much important, particularly in the remote sensing process. Coming to that, the remote sensing platform. When I say the remote sensing platform, there are platforms like ground-based platform, aircraft platform, space shuttle platform, and satellites. So I just show like how we represent a platform. The first one, we have a image, the ground-based platform for collection of like information. Like commonly we have seen like in any signals, in any circles for monitoring the traffic, we use the various ground-based platform. So from that, the monitoring of various factors. And then there are so many times we collect information through aircraft by fitting a sensor camera in the base of aircraft. We collect the information called aircraft. Then some other time we collect the information through space shuttle, that is arbitrary path. And nowadays, whatever that information we need, we collect either by space shuttle or satellite, the base or sensor systems. So generally, these are the four important the types of remote sensing platforms. Coming to that, the data collection from the platform. So that always depends upon the height, that it may be a higher altitude or lower altitude. So depending on the various several considerations, we are going to be collect the data. So most of the time, so the satellite sensors altitude in order of 600 to 900 kilometer. In between that, the data will going to be collected either the factors of high altitude or low altitude. So depending on the requirements that we are going to be collect the data through the ground observations. So coming to that, the remote sensing orbits, we have satellites. When I say satellite, it is an object or a man-made object or natural that revolve around the earth. So any satellites, depending on their specification, depending upon their target of path, it revolve around the earth and continuously capturing the data. That data we are going to be received in the receiving station. When you speak of orbits of remote sensing, we have remote sensing sensors. Sensors are sophisticated devices that are frequently used to detect and respond to that electrical or optical signals. So there are types of orbits like low Earth orbit, medium Earth orbit, high Earth orbit. These are the three types of orbits. Low Earth orbits, like arbitrary path covering an altitude of less than 2000 kilometer, we call LEO, low Earth orbit. So if it is the arbitrary path in order of the 2000 to 35,789 kilometers, we call MEO, medium Earth orbit. And then high Earth orbit, so more than 35,789 kilometers arbitrary path of sensor system will be called high Earth orbit. Coming to that, the types of orbits like geo-sun synchronous orbit and sun synchronous orbit. So these are the two distinguishing types of orbit that depends upon the altitude. So geo-sun synchronous orbit, like arbitrary path of satellite sensors at an altitude that is a geostationary in order of more than 35,000 kilometers, we call the geo-sun synchronous arbitrary path. Sun synchronous arbitrary path, so it will covers the entire Earth. So the arbitrary path of that particular sensor system covering a 700 to 900 kilometer in the polar arbitrary path. So repeatedly, frequently, we are going to collect the data by this, the polar arbitrary path, that is a sun synchronous arbitrary path. But in general, these are the two types of satellites orbits. So coming to that, a collection of data or the aerial photographs or the photogrammetry or any means of the remote sensing data collection, the digital map and remote sensing sensors. When I say the digital map, most of the time in the process of remote sensing, we have say like it is a set of two like hardware and software components. So whatever that the process that we carried out, particularly in the part of remote sensing, all are related to the hardware components. Through these hardware components, whatever the data we are collected, and then the use of software, whatever that outputted data we obtained, that is a GIS. So particularly any applications of remote sensing, that needs a digital map. When I speak a digital map, there are a lot of procedure, a set of consideration for creating a digital map. For creating a digital map of any particular area, the base will be that cadastral map. That is a survey map. The use of survey map that will going to be scanned and put it in AutoCAD and then start digitizing that scanned map. So during the digitization, there are set of procedures to be followed by following first we are going to be draw down the polygon line and then line features. So difference that we have noticed between the polygon and line features. Polygon means when we draw when we start digitizing that any map. So starting point and ending point of the nodes will be in the same point we call polygon. A good example like roads or boundary, a good example. Then coming to that line features, there are numerous nodes. Wherever it gets end, there will be no continuity. We call line features. Good example, streamlines, footpath, car track, etc. Or drainages. Once we create that, all the boundary line with respect to that color pattern. So always, whatever the digitization, that includes all the set of features will be assigned with a set of color, like roads are with a red color, boundary with a yellow color. And then after drawing all the features by representing a color, then cartographical features are inserted. So in this particular cartographical features, depending on the what type of object or entities in that particular area, we are going to be create a small tree, big tree, temple, symbol for temple, borewell, church, etc. So all are created and inserting. And then after inserting, once again, it will be verified with the surveyor, with the survey map. And then the same map that we are going to be carried, bring to that particular area and verified, is there any missing data? After once again entering the missing data, then georeferencing of map will be carried out. Now the picture come, the satellite imageries in the georeferencing. Once we start preparing a digital map, that digital map will be subjected to georeferencing by use of satellite imageries. The same area, satellite imagery will going to be downloaded. That is, high resolution images are downloaded. The georeferencing of that area, the point that we are noticed in the map, the same point that we are going to be identified in the satellite images. So similarly, there are n number of points are noted. Automatically, after 5 to 6 points, that itself select a point, exact position. If it is, and then finally we are overlapping that the prepared digital map and satellite map. It's completely overlap without a 0.1% of error, then only we call georeferencing. Particularly in the remote sensing and GIS, one of the toughest job, the georeferencing. So once that georeferencing of digital map will be completed, then we can use that map, digitized map, for n number of applications. So this will be the way that creating a digital map by use of various digitization processes. So after that, when you come to that, the remote sensing sensors, there are two types of a sensor: passive sensors and active sensors. So passive sensors, it will measure the energy that is naturally available. This can be only taken place during the time when the sun is illuminating the earth, called passive sensors. A good example, human eye. When there is a light, it will capture the object. When there is no light, our eyes cannot capture anything. Similarly, the passive sensor, it will measure the energy that is naturally available when the illuminating the natural energy radiation is available. So when we speak of active sensors, it will provide their own source of energy for illumination. The advantages of active sensor, it includes ability to obtain the measurements at any time, the regardless time or day or session. A good example, radars. Good example of active sensors, radars. So in this particular, you are very much careful about the examples of active sensors and passive sensors. This is the one image that greatly shows how that eliminating their own source of energy. In the passive sensors, like already I will tell you, like the pattern that is passive sensors, when there is energy radiation, it will capture that particular object. But here in the active sensors, if you see that another illuminating energy that will like capture the data regardless time, regardless season. Coming to that, the characteristics of a sensor, generally resolution. The characteristics that based on the resolution. Resolution, it is a broad term. There are generally 4 types of a resolution, like spatial resolution, spectral resolution, radiometric resolution, and temporal resolution. Spectral resolution, when I speak a spectral resolution, a specific wavelength interval that sensors can record called spatial resolution. So spectral resolution. When I say spatial, it always represented with a peaks of grids that represent a spatial resolution. If you see the image, the spatial resolution, like difference of images with 1 meter, 3 meter, and 10 meter. So in the 1 meter, you have very clear cut the identification, but the identification is not done with the 10 meters. So such a images we call a spatial resolution. Then the spectral resolution, spatial resolution. Similarly, with the interpretation of spatial resolution with the various bandwidth, the WIPKI are from 1 kilometer to 1 meter. So in the 1 meter resolution, we have clearly identified what exact the area, but here 1 kilometer we are just represented with the shades of color. And radiometric resolution, among all other the various types of resolution, the radiometric resolution is of very much important because always it is assigned with a value of the bit in terms of a grids. So every bit, whatever that grid representation in the radiometric resolution, that will be is of greater value. So in the image that will show the various grids. So when I go in depth study that object, every grid will be assigned with a value. When I go deeper and deeper by focusing on a bit of value, so finally we get a high radiometric image, what exact that object is. So always the value will be ranges from 0 to 255 for each pixel. So similarly, depending on the 7-bit, 5-bit, 6-bit, 8-bit, so the grids will be varies. So depending on that bit value, if you see that 6-bit, that is the grids will be 0 to 63. If it is a 8-bit, the value will be 0 to 255. 10-bit, it is in order of 0 to 1000 plus. That is a radiometric resolution. Another one, the last type of a resolution, temporal resolution. So temporal resolution, it is often a sensor obtain imagery of a particular area. This is the one imagery, temporal resolution taken with the list camera of a particular area, a good example of KRS catchment area. So if we see that catchment area, just if I go in depth with high resolution, I have a very much clear picture. But in general, the temporal resolution, it looks that it is a drainage pattern with irrigated and unirrigated area. So coming to that further more about the remote sensing Indian satellites. So father of Indian space program, that is Vikram Saripapa. And when I look at the history of satellites, the world first satellites was launched in the year 1957. And then in the year 1975, Indian space program will be started with the Aryabhata. So focusing on that Indian space program from 1975 to the 80 to 85, from one decade, from 1975 to 1985, there are n number of satellites are launched by Indian space, but all the whatever that launching vehicle, all are a experimental satellites. So experimental satellite in the sense to gain a knowledge in that particular satellite space program, they will launch more number of satellites and provide the knowledge how to settle that in an arbitrary path and how to download it the particular resources and how to interpretation that obtained data. So in the year 1962, Indian National Committee on Space Research at Ahmedabad, and then in the year 1963, the first sounding rocket was launched on the November 21st. And then in the 1967, the experimental satellite communication Earth station was established at Ahmedabad. And then in the 1969, the Indian Space Research Organization, that is ISRO, was established. So after establishing the ISRO, so from the 1980s to till date, within 2 to 3 decades, the rapid growth of Indian space. So in India, we have the various satellite launches. So ISRO has successfully developed a complete array of launch vehicle launchers like SLV-3, ASLV, PSLV, GSLV. Among all other launching vehicle, I am just concentrating PSLV and GSLV. PSLV, it is a polar satellite launch vehicle. That is, any satellite sensors, they have an arbitrary path focusing on in order of 600 to 900 kilometer altitude. We call PSLV platform. In the case of GSLV, it is a geosynchronous satellite launch vehicle. The arbitrary path of sensor satellites covering more than 35,000 kilometers, we call GSLV platform. So this is the one platform. I just show the platform launching the satellites, PSLV platform. Similarly, the GSLV, but the capacity launching the pattern will be varies, covering in a higher altitude. Coming to that Indian space, the national space system. So from last 3 decades, whatever that Indian space will be achieved. So with the programs of INSAT satellites and IRS satellites. So from 1975 to till date, nearly more than 110 satellites are launched by the Indian space. So in that, nearly 10%, 8 to 10% of satellites are not successful, the failure one. But the success rate of Indian satellites in the recent decade, from 2 decades, will be 80 to 90%. So these are the experimental satellites in India: Aryabhatta, Bhaskara 1, Bhaskara 2, and then Rohini series, and then INSAT series. So till date, there are a few INSAT satellites are still in a working condition. Every repeated period of time, we are going to receive the data. But the more and more successful of Indian space program, IRS series of satellites. Already more than 50 plus satellites are launched. So every year by year, there are n number of satellites are launched. So the objective of launching satellites, improve the sensor system. But because every set of satellites have a specific period of time, their working condition will be 2 years, 3 years. So within that 2 years, once again, that sensor system will be upgraded and resending that another some more satellites for continuation of that whatever that capturing data. The important set of satellites in the IRS 1C, IRS P2, IRS P1, IRS 1A, B, then ResourceSat, Cartostat, Oceanostat. So like that, the n number of more than the 40 to 50 satellites are launched. So the most important set of sensor system in the IRS, LIS camera. So LIS camera, it is the worldwide one of the best sensor camera, high sensitivity camera for capturing the data with higher altitude. So LIS camera will capability of capturing the various bandwidth. So varies with the electromagnetic spectrum, it has a capturing the bandwidth in order of at a time it is possible to cover 80 to 90 kilometer length and width of 52 kilometer. So there are so many times the area will be extending, but only thing, the resolution will be varies. If we want to collect a higher resolution, the area will be compressed. If we get a higher, large area, the resolution will be completely invariable. So coming to that list schematic, the sensor in the satellite. So whatever that launching vehicle, this will be the sensing devices. There are n number of sensor cameras are fitted. So each camera will be monitoring in their specific bandwidth. So if we specification the blue color of spectrum, that camera will be work out on that blue color only. Specification with red color, it will work with red color only. So capturing data will be with respect to that specific bandwidth. So the important set of sensor camera in IRS series like list 1, list 2, list 3, list 4. So and then advanced wide field sensor. List means linear imaging self scanner. Linear imaging self scanner, self scanning system. And then the advanced camera in the list, that is a list 4. It is a high resolution linear imaging self scanning system. So some other important set of sensors in IRS, that is a YFS, WIFS, that is wide field sensor. So AWIFS, that is a advanced wide field sensor. Apart from this, there are so many other sensor camera, panachromatic camera, and other various camera for monitoring a particular related the bandwidth capturing process. Coming to that, some other importances after collecting the data, we have image processing. So important, the process including in the image, like image, the processing of image includes enhance the quality of picture by radiometric resolution, or enhancing the sharpness, or classification of images, accuracy assessment classification. So through these various correction, the image processing with the various frequency domain. Generally, there are two frequency domain. One will be the spatial domain, and another one like in the spatial domain. So particularly, it includes the manipulation of image, like direct manipulation. Whereas in the another domain, like frequency domain, in this technique, the manipulation of Fourier transform. So behind it, the various geometrical classification involving for the various corrections. So a good example for the frequency domain with the shades of color with a bit of color, 2-bit image and 8-bit image. So only thing through these various color enhancing technique, so enhance the quality of image. So 2-bit and 8-bit. Similarly, if we furthermore enhance the quality, we go for 16-bit and then 25-bit like that. Then that is the part of a hardware component, remote sensing. Now, a software component, whatever the data we are going to be collected through the various sensor system, now we are going to be work out with the software, that is a GIS. Geographical Information System. It is a set of tools for collecting, storing, retrieving, transforming, displaying geographically referenced data we call GIS. The important components of GIS includes a set of people, hardware, software, data, and the various processor. The process of GIS includes capturing data, register base map, interpretation of data, convert data, then store data, process data. Finally, we have a display data. This is the process include from starting point, capturing data, that is from remote sensing to the software running the display result. The types of software widely used in the GIS, Grass GIS, Job GIS, Map Window GIS, and then ArcGIS, EDARS. So EDARS, the full form of EDARS, Earth Resources Data Analysis System. There are different versions of ArcGIS and EDARS-GIS. So from this advanced software, the most of the environmental application or civil engineering application will be carried out. So in this, the software, like whatever that the data collected, so through this spatial data and attribute data, the enhancement or the work of GIS with the two types of data model, that is a raster data model and vector data model. Raster formats always generalize with the grids. So whatever the objects or entities or anything that will be represented with the grids only. So we call raster format. And then vector format. So always it represents the features in terms of a point, line, or polygon. So same thing that we represent in the raster in terms of a grid. Here, the whatever that represented, that will be represented through the representing like points, lines, or polygon. So this will be the another picture shows the representation of raster and vector data. So by combining that, we get a real world picture. So one the advantage of this raster and vector data, initially we create a vector data layer by layer, all the various layers like road, parcel, elevation, land use, and the settlements, everything will be created in a layer. And then overlaying all the created layer, we get a real world picture. So at any period of time, or based on the requirement, we can convert the data into a vector data to the raster data to the vector data. So these are all the important set of the remote sensing applications. The presently very much applicable in the agricultural and crop study, forest study, water resources, geological study, ocean and coastal study, environmental study, rural management, urban management, cartography, global change, strategic plan, land and water resources, natural resources information, or disaster management. So more than that, in most of that engineering application, a good example like any flyovers or any route alignment that was successfully done, the route map will be successfully created by use of this remote sensing and GIS techniques. So these are the important set of remote sensing application. So that application was successful by use of a part of contribution with the GPS. When I say GPS, it is a global positioning system. It is only the system today able to show your exact position on the earth at any time, anywhere, under any condition. So there are three important parts of GPS. One will be the satellites, another one the receiver, and another one software. So coming to that GPS, it is a precious positioning system. Initially, earlier, that GPS was completely developed and maintained by US Department of Defense. And it has consisting of a satellite like 24 based like arbitrary path of satellites. So most of the satellites will have an arbitrary path like the polar arbitrary path covering altitude of 20,200 kilometer higher orbit. So if any space program, if they have an arbitrary path of 24 satellites, they have ability to maintain that the GPS system. So India earlier, like 2 years back, India will also completely depends on the US defense, because for anything, for any new updation in the GPS, they need authority, whatever that the various factors that will be obtained from the US only. But nowadays, India will also qualify the number of the satellites arbitrary path in the various the arbitrary path. So they will maintain their own the GPS devices and create their own various specification path. Coming to the GPS, there are three segments: space segment, control segment, user segment. A simplest the various instrument for collection of data. So space segment, it is a segment of constellation of 24 satellites. So arbitrary path, 24 satellites. And control segment, with that space segment, the receivers, the signals are capturing from these antennas. That is a control segment. And then user segment. The user segment includes what type of portable GPS that we were used for collection of data. These are the three parts: space segment, control segment, and user segment. So most of the time the expected question, and there are one time the question may asking in this particular GPS how it works. So even though we are saying like 24 constellation satellites for satisfactory working of GPS, the measurement of GPS, like it will be work from the 4+ satellites. So in that 24 constellation, if it will be a 4+1 satellites, so automatically the GPS work with a satisfactory condition. So that measurement will be with factors like distance is equal to time travel into speed of light. So this is the way the 4+1 satellites So with that calculations, the GPS will be work. So on this particular 4+ satellites, there will be a one time in the gate examination, they will ask a question. So coming to that, the advantages of GPS. So more importantly, it will replace all the conventional system and the global coverage, battery accuracy, 3D data, and huge the velocity of data, predictability and reliability. So these are the set of advantages of GPS. So earlier, GPS will be utilized only for the defense purpose or defense related activities. But nowadays, the GPS is available for a common civilian usage. So everywhere for locating the vehicle or tracking the vehicle or route system for any purposes, we have used these GPS devices. The common use of GPS, GIS, data collection and mapping, navigation purpose, recreational purpose. By this, the use of GPS, it always saves a time and money, particularly in the survey practices and the creation of map. So these are about the GPS. With this combination of remote sensing, GIS and GPS, always we have created a wonder and we done a better work. The information in the Google Earth is obtained through the remote sensing, the representation and the management remotely sensed data on a geographical location is made possible through this, the advanced mitigation tool GIS and Geo-informatics. So with this, the summary of today's my presentation covering the development and history of aerial photographs, types of photographs and map scale, introduction to the remote sensing, and introduction to the GIS and GPS. So with this, today I'm going to be concluded my session covering a part of the Geomatics Engineering, the part of remote sensing and GIS. Thank you, one and all.
Thank you, Professor.
Thank you, one and all.
Thank you, Professor Girish sir. I thank all the faculty members, all the participants for your patience.
Thank you,
and I request all the participants to join us for tomorrow's session on water quality and treatment by Professor Shilpa BS and fluid mechanics and hydraulics by Professor Girish. And kindly don't forget to give your feedback in the chat box. And I request all the participants to join us for tomorrow.